Today we're taking a look at scalar multiplication. So this is going to be a lot easier than the matrix multiplication because scalar multiplication is simply distribution with matrices. So what you're going to take the number on the outside, multiply it inside. So we're going to take a look at 3 problems from you guys' packet. We're going to also look over this example right here just to introduce the idea. So we can multiply an n by n matrix by any scalar k. So what we're going to do first off is just take this k, we're going to distribute it to the a, to the b, to the c. That's how we end up with this over here. So now if we take a look at actual numbers, this problem is going to have scalar multiplication also with subtraction of the matrices. So to start off with, we have a 3 right here, and then we're going to have to distribute that into these points. We're going to do the same thing for the second one. So this problem is about as hard as these can get. So if you're able to follow along with this one, then you're going to be able to do all of the problems from this part of the section. So we have 3b minus 2a. So what we're going to do is just 3 times the matrix b, and then minus 2 times the matrix of a. So that's how they get this problem right. This part, it comes from this. So now we're going to just go through and distribute. We have 3 times a negative 1, 3 times a 5, 3 times a 7, 3 times an 8, and then we just rewrite these in this process. Second part is going to be the 2, so we're going to have a negative here. We're going to do 2 times 4, 2 times 0, 2 times a negative 6, and 2 times a 3. So we go through and just figure out the multiplication here. You shouldn't need a calculator on these again, but you can always use a calculator on any of the steps. We have a negative 3, we have 15, 21, 24. These are just coming from the quantities, 3 times 8, that's where the 24 comes from. So just make sure you rewrite those into the same spots. Now we get to the subtraction. This is what we were just looking at on the last video. We have negative 3 in the first spot, 8 in the first spot of my second one. So it's negative 3 minus 8. It's important to remember here though, if the dimensions don't match up, still can't do this problem, it will be not possible. Then we have the 15 minus 0. We'll just work our way through each of the steps right there. So the first one we're going to look at here is just scalar. There isn't any addition or subtraction here. So we start off with, we have a 6 right here. I need to distribute this to each of these terms. So it's going to be 6 times 2, 6 times a negative 5. I'm going to write these out with parentheses. 6 times 3, 6 times 0, 6 times 7. So with scalar multiplication, it's nothing to be scared of. We just have to go through and do the steps. If you take your time, write it out as I'm doing here, you shouldn't have too much room for mistakes yet. The next section is going to be a little bit harder, but the calculator takes care of most of that work for me. So now I'm just going to go through and do this part. I have my matrix is now going to be 12, negative 30, 18, 0, 42, negative 6, negative 24, 36, and 72. If I make a mistake on any of these, let me know. If you are the first one to tell me that, I will give you extra credit. This is example number 1. Just go through 6 times all of the quantities, scalar multiplication. This is also how we would do dilation, which we'll get to later, but this would make an object look bigger. Next one, number 2, same type of idea, but I want to do this problem for you guys because of that fraction in there. I know a lot of you guys don't like the fractions still. I think most of you can do them, you're just a little bit uncomfortable with them. When I multiply by a 1/3, it's going to be the same as dividing by 3. So if we go through and do that, that's going to make this a lot neater. So to start off with, I'll write this one up at the top. We got 6 divided by 3, but this term is going to become negative. All the signs on here are going to change. So I have a negative 15 divided by 3. I have a negative 9 divided by 3. So all I'm doing here is I'm dividing by 3. It would be the same as saying 6 times 1 and then dividing by 3, but since 6 times 1 is always just going to give me the number, we have that. We also have to introduce that negative though, so if it is a negative, it becomes positive. If it's positive, it becomes a negative. So now I have negative 51 divided by 3, negative 33 That was negative, so now it becomes positive, divided by 3. $18 was negative, so it becomes positive. Okay. So we have 6 divided by 3 is going to be 2. We have negative 15 divided by 3 is going to be a negative 5, negative 3, negative 17. Sounds good. We have 11. We have 8, negative. We have 6. I have a negative 1, and I have a negative 15. So that is my answer to number 2. So again, on this you can use a calculator if you really don't like those fractions. But most of these problems are going to be neat for you, so they come out to be whole numbers as you divide by the 3. We're going to take a look at one more. This is going to be, again, one of the harder problems. It's going to be using addition in there as well. Take note of the parentheses on this one. Remember my please excuse my dear Aunt Sally. So on this one I have to do inside the parentheses before I can do my distribution, which in this case is going to be nice because if I try to distribute the 1/4 into that 9, I end up with a fraction. But these numbers are going to be a lot prettier if I do the addition here first. So the first one, when I do addition, this one located in row 1, column 1 goes with the one in row 1, column 1 of the second matrix. So it's 9 plus 3. I have 1 minus 5. Negative 7 plus 1. And then I have 0 plus 7. So this is step 1. So now I'm going to go through and just fill out my numbers. So I have 9 plus 3 is going to be 12. 1 minus 5 is a negative 4. Negative 7 plus 1, that's not going to give me a pretty number, but it's going to be a negative 6. Over here we're going to have 0 plus 7 is just going to be 7. So this is step 1. Step 2. Okay, so now this is going to be after the addition. So now step 3. I want to look at the scalar part of this. So I'm going to bring my matrix from right here over. And now I'm going to rewrite my 1/4 right there. So I have 12 divided by 4 gives me a 3. A negative 4 divided by 4 is negative 1. Now I'm going to have a negative 6 over 4. I'll reduce that in just a second. And then I'll have a 7 over 4. So when I multiply by 1/4, this is the same as on the example with the negative 1/3. I just need to divide by 4. So that is how I come up with these numbers. You guys may use a calculator on those as well. Now on this, I can reduce this negative 6/4. So I could have done that in that step, but I didn't. So I'm going to rewrite this with that reduced. So the 3 and the negative 1 stay the same, but now this one, they're both even. So 2 can go into both of them. 2 goes into 6 3 times. 4 has 2 going into it twice. Now 7 and 4, those don't have any numbers in common, so I have to leave that as it is. That is my answer to number 9, and that is about as hard as these ones can get. So on this, I have the addition and subtraction, but I also have a fraction. Again, those fractions make these a little bit more difficult, but for the most part, we can plug these into a calculator if you're not comfortable. I know a lot of you guys will be able just to do these ones by hand. So we write these out, steps 1, 2, 3, and we just simplify it after that. This is going to be the scalar multiplication. This is section 4.2.